In the world of pulp and fiber, every stage of the pulp molding process is critical to producing quality pulp molded products. Among the many stages, the drainage stage stands as one of the most pivotal, as it dictates factors such as product strength, consistency, and production speed. To avoid issues like weak spots in the final products, or surface imperfections, and extended drying times, you will want to ensure that you outfit your screens with materials that promote efficient production. Woven wire mesh, for example, delivers a balance of fiber retention and water throughput that most pulp molding processes will benefit from. But is it right for your process? That's the question. During the pulp molding process, the drainage stage is one of the more critical steps in ensuring high quality, durable molds. Drainage typically takes place immediately after the slurry is deposited onto a wire mesh mold. During this stage, a vacuum system is deployed to extract the excess moisture from the slurry molds. In turn, you are left with a uniform layer of fiber that forms the final product. When done properly, excess moisture is removed from the mold while ensuring optimal distribution and consolidation of fibers. That said, the drainage process affects things like the product's form. Drainage controls how well the fibers settle across the mold. This is reflected in the presence or lack of weak spots or inconsistencies. It can also affect the product efficiency. How well your molds are drained dictates the drying speed. If the molds are not drained properly, more time and energy are required to ensure quality products. And the drainage process can affect structural integrity. How the fibers consolidate during the drainage stage will influence the strength, durability, and performance of the product. So a dependable pulp molding process relies on optimizing the drainage stage. So like I said before, your drainage process ultimately controls the quality and sustainability of molded fiber packaging and products. Failure to implement reliable drainage can cause imperfections like uneven thickness, weak bonding, and prolonged drying times. This can not only slow production times down, but it can also create more material waste. It is important that factors like vacuum pressure, mold design, and slurry composition are fine-tuned in accordance with your process. Doing so can improve product consistency, reduce waste, and enhance the overall efficiency of your process. In short, the drainage stage lays the foundation for strong, lightweight, and eco-friendly molded fiber products. You'll want to invest in quality wire mesh molds and optimize vacuum performance to enhance the sustainability and profitability of your process. It's because of this that the drainage stage is paramount for those seeking improved production output and product quality. By effectively removing excess water, you allow the fibers to settle evenly, promoting uniform fiber layer thickness while combating weak spots and deformation. Proper drainage also works to reduce rough surface textures, fiber clumping, and other surface inconsistencies that can affect performance. Implementing a controlled drainage process will afford the ability to prevent excessive fiber placement. In turn, your molded fiber products will deliver consistent density and mechanical strength. Failure to drain your molds properly can cause several integrity concerns, including warping and brittleness. This again can increase production costs and material waste. There are a number of challenges that can affect the drainage stage of your molded pulp fiber process. Concerns such as inconsistent drainage rates, wire mesh clogging, and poor fiber retention all have the potential to affect product efficiency and quality. Something else that can cause hiccups in your drainage process is variations in pulp slurry composition, fiber profile, and vacuum pressure. These three factors all have one thing in common. They can cause issues with water removal, leading to structural defects in the molds and extending cycle times. To that end, when fine-tuning the pulp slurry composition, fibers or other debris may clog the openings of the mold screen. These clogs subsequently lead to slower drainage times, disrupting fiber distribution and surface imperfections. Now, when it comes to the screens themselves, operators often run into issues with fiber retention, specifically screens allowing too many fibers to pass. Naturally, with fewer fibers being molded, poor fiber retention results in weaker, thinner products that break easily. More often than not, these issues can cause manufacturers to halt production, to clean, adjust, or replace their molds. Of course, this means increased downtime and operational expenses. Failure to address these issues means there is increased water excess. The more excess water present in your molds, the longer drying will take and the more energy your system will consume. Woven wire mesh, or simply wire mesh, is a durable, versatile screening material that consists of hundreds of individual wires woven together into precise, uniform patterns. Known for its exceptional strength, precision, and permeability, woven wire mesh has become one of the more prominent screen options used for pulp and fiber. Virtually every aspect of mesh can be customized, ensuring a perfect fit. This includes the aperture size, wire diameter, weave type, alloy, and thickness. When each section is methodically selected, you will find that wire mesh can provide the perfect balance of cost effectiveness and long-lasting performance, unlike any other material on the market. Woven wire mesh offers several functional benefits. However, it plays a critical role during the drainage stage of the pulp molding process. It provides optimal water removal capacity, fiber retention capabilities, and the ability to be formed into the desirable molds with ease. Typically paired with CNC machine molds, wire mesh serves as a highly efficient filtration layer that works to deliver desirable pulp consolidation without sacrificing drainage speeds. Now, as the molds are introduced into the pulp slurry, the vacuum system pulls the slurry through the wire mesh openings. You are then left with fibers that are formed into a uniform, structural, secure product. And a key advantage of wire mesh as a pulp and fiber mold screen is the sheer level of customization that it offers. Specifically, you can have complete control over the pore size of the weave, affording the perfect balance between fiber removal and water retention. And I just want to put it out there that W.S. Tyler does offer a specialized 24 and 50 mesh weaves that are specifically made for the pulp fiber process. Each weave has distinguishable characteristics that are lab tested and proven to promote a more efficient pulp molding process. Hashtag sponsored. This balance helps combat fiber loss and speeds up drainage times, thus minimizing drying times and energy consumption. Another advantage of note is the material combination of the wires used to weave wire mesh. As stainless steel is typically used to weave wire mesh, it delivers peak durability and resistance to vacuum pressure, heat, and corrosion. This will ensure that your wire mesh screens can provide long-term performance. Despite its superior strength, woven wire mesh remains highly formable, allowing it to conform to most intricate mold designs. As a result, the risk of inconsistencies such as weak spots, thickness variations, and surface imperfections is minimized. Not to mention, by customizing wire mesh to your specific application, clogging concerns will become a thing of the past. This in turn will minimize production downtime and maintenance requirements. So put simply, integrating woven wire mesh promotes superior product uniformity, increased production speeds, and reduced operational costs. Selecting the right woven wire mesh specifications for optimal pulp molding drainage requires methodically balancing mesh count, wire diameter, alloy, and cost efficiency. Mesh count determines drainage speeds and fiber retention. High mesh counts capture more fiber but slow drainage, whereas lower mesh counts drain faster but also allow more fibers to pass. Wire diameter affects the overall durability of the wire mesh screen and the percentage of open area. Thicker wires promote longer lasting weaves but increase drainage times, while thinner wires produce faster flow rates but wear faster. And alloy controls the corrosion resistance and durability of the mesh. It is critical that you and your engineers work closely with your wire mesh supplier to optimize these factors. Doing so will ensure enhanced drainage efficiency, product quality, and overall production performance. Thanks so much for watching. If you have any questions, click our Talk to Us button to get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things W.S. Tyler. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.